committed or would like to do well on the test, this is probably the best 30 to 40 minutes you could spend studying for this, studying for the tests. Okay, so first some date stuff. Today is the deadline for the digital portfolio. I'm no longer able to help you with any of that. I'm not staying after school. We've been working on this for like 6 weeks, so like the deadline was coming and you knew it. We've been talking about it for a long time. Okay, the multiple choice exam is next Monday at noon. Almost all of you are in the auditorium. You should have gotten some sort of location, and you probably got a ticket, a test ticket sent out. I don't know. Either way, today is actually the last day I'm going to see you before the exam, because I'm not going to be here Wednesday, Thursday, or Friday of this week. But you will be here probably Wednesday and Friday. And there are two main units that we have not covered yet, for which there will probably be 4 or 5 questions about, at most, from each of them, which is not a ton out of 70 questions, but it is several. And so we're going to talk about those 2 units, specifically the pieces of information you need in order to get those questions correct. The one category, or the one unit, is algorithms. Okay, algorithms are any sort of set of instructions used to solve a problem. The questions about algorithms will either be something like where you get a flow chart. Okay, the flow chart is a visualization of an algorithm. Program code is an algorithm, but algorithms in general are just however you're explaining a set of instructions. But the questions are either going to be about like, what is an equivalent for this? Or they're going to be about algorithms in general, like developing them, or reasonable time or unreasonable time. Okay, there's a lot of like very specific things that you need to just remember for a few days. You don't need to come up with examples. Just, it's unfortunate, but that, rote memorization is the best bet. But we spent in a different class period talking about that for 50 minutes. And sometime before the test, you should watch that video and listen to it, most importantly, listening to it, where I go through and explain all of those things. Hopefully the audio is good.
More computers.
You probably want to listen to it on like 1.5 speed, but still good stuff there. The other topic that we're going to talk about here and make a recording so that other classes can watch it is encryption and decryption. Well, encryption in general is the category. There is also a unit data, but questions from this unit are really things that you should just know because you are a digital citizen, things you should have known, or you should know being a member of the world, things like crowdsourcing. You should know what crowdsourcing is. And something like data bias, even if you've never heard the phrase data bias, it's bias in data or about data. Okay. And like a lot of the questions that would be related to that are things like this last, just to let you know, the documents I'm going through are the 3 practice tests all together as a PDF, which are the same practice tests as from here from AP Central that I have made duplicates and you can take if you want. I do think you might be better off studying from the PDF because you can search for questions about algorithms through all 3 of them, where you can't search through the AP practice tests, the ones on AP Central. So that should be useful. Unfortunately, this PDF doesn't have the answers in it, so you would need to actually go through the tests and do them. Even if you don't do well, you get access to the answers after you finish it, so you can go through and the answers line up, or the questions line up exactly. Okay, but either way, excuse me, the questions about data and that sort of thing are going to be a lot of questions which are really more like reading comprehension. Like here, this 5 questions about this proposed app that allows joggers to put in their location, and it keeps track of their running and finds them other people to run with of similar abilities and gives them good routes and that sort of thing. And using only this information and no like inferred information, answer the questions. Things like, you know, from a variety of different categories, like what is most likely to be a data privacy concern based on this description? There isn't really a way for me to prepare you for a question. I mean, I could prepare you for this literal question, but questions like this for you to go through and sort of parse out what parts are relevant to data privacy. You just have to read and comprehend. Okay. What is most likely to be a benefit of this type of thing? And like, it's really more logic and English than it is computer science, but take some time and do this. And okay, so encryption. We're going to keep this to very high level, meaning high level means simplified and abstracted aspects of these concepts. Just a few like short phrases you could hang your hat on and say, these are facts and these are going to be the answers to a few questions. We're going to watch a brief short video about encryption, about the 2 general concepts of encryption, symmetric and asymmetric. Okay. Asymmetric is also called public key. You'll see why in a second. And we'll do a brief explanation, and then we'll go through like the 5 or 6 questions from there that are related. Okay, so.
Encryption is the process of taking a message and scrambling its contents so that only certain people can look at the message. There are 2 types of encryption, symmetric and asymmetric encryption. Let's first take a look at symmetric encryption to understand why asymmetric encryption was created. To do that, let me introduce you to Alice and Bob. Alice has a sensitive document she wants to share with Bob. She uses an encryption program to protect her document with a password or passphrase that she chooses. She then sends the encrypted document to Bob. However, Bob cannot open this message because he doesn't know the passphrase that Alice used to encrypt the document. In other words, he doesn't have the key to open the lock. Now comes a real problem. How does Alice share this passphrase securely with Bob? Sending it through email is risky because others might find the passphrase and use it to decrypt any messages between Alice and Bob. This is exactly the kind of problem
Okay, so this video is a little misleading. Everything they've said is true. The idea that symmetric encryption means that both the sender and receiver are using the same key to encrypt and decrypt. The problem is you can't then also send that key across the wire. Symmetric encryption or single key encryption works. The problem is you have to agree on the code, the secret code or what have you, before you part ways. You have to physically be in the same place. You can't send the password along with the message, but it does in theory work with that shortcoming. The problem is that when you're doing business on the internet, you want to send things securely to somebody you've never met before on the other side of the planet or anywhere. And you can't do that with symmetric encryption. You can do it with asymmetric encryption.
And use This is exactly the kind of problem that asymmetric encryption attempts to solve. It is comparable to a mailbox on the street. The mailbox is exposed to anyone who knows its location. We can say that the location of the mailbox is completely public. Anyone who knows the address can go to the mailbox and drop in a letter. However, only the owner of the mailbox has a key to open it up and read the messages. So let's now go back to technical details. When using asymmetric encryption, both Alice and Bob have to generate a key pair on their computers.
Okay. This is the answer to one of the questions, worded somehow. Asymmetric encryption, also known as public key encryption, requires both sender and receiver, or requires every receiver. Everybody has two keys, a public key and a private key. That's why it's called public key encryption also. Okay, that is one of the questions, or one of the answers. Two keys. Everybody has their own two keys that are related, but you won't have to worry about the details of why.
A secure way for doing this is by using the RSA algorithm. This algorithm will generate a public and private key that are mathematically linked to each other. Public keys can be used to encrypt data, and only the matching private key can be used to decrypt it. Even though the keys are linked together, they cannot be derived from each other. In other words, if you know someone's public key, you cannot derive its private key. If we retake our mailbox example, then the mailbox's address would be the public key, something that everyone is allowed to know. The owner of the mailbox is the only one who has the private key, and that is needed to open up the mailbox. Let's now take a look at how Alice and Bob can use asymmetric encryption to communicate securely with each other. They start by exchanging their public keys. Bob gives his public key to Alice, and Alice gives her public key to Bob. Now Alice can send her sensitive document again. She takes the document and encrypts it with Bob's public key. She then sends the file to Bob, who uses his private key to unlock the document reading. Because they use asymmetric encryption, only Bob is able to decrypt the message. Not even Alice can decrypt it because she doesn't have Bob's private key.
It's kind of a useless statement, because why would she want to decrypt the message? She just encrypted. She knows what the message is anyway. But the point is, having anybody has Bob's public key and they need it to encrypt the message, but only Bob can decrypt it because he has the private key. That's all you really need to know.
Asymmetric encryption now relies on Alice and Bob to keep their private keys well protected. If an attacker steals Alice's private key, it can be used to decrypt all messages that are intended for Alice. However, the attacker cannot decrypt messages that were sent by Alice because that requires Bob's private key. Asymmetric encryption is used in a lot of places where security really matters. It might not be clear action.
That's nice, but it's irrelevant where it's used. Okay. Unfortunately for computer science topics and a lot of things, that explanations for the topics either fall into the unbelievably simplified or oversimplified category of explanation, or way too detailed and are just, master's, PhD level classes, just of people talking for hours and hours. This is a hyper simplified explanation of this topic. The mathematics that go into it are super complicated, that making it easy to create a public key or a key pair and encrypt easy for computers, and like would take millions of years for a regular computer to break the code, if it's possible at all. But we're not getting into the details. The details for this are everybody has two keys, a public and a private key. It allows messages to be sent to strangers, to to intended recipients securely across the wires, they would say, meaning like on the internet, even if it's just, Wi-Fi or radio signals. That's encryption. Okay, let's take a look at a few of the questions. And some of the questions that come up when we search encryption will be answers to questions that have nothing to do with encryption. The test writers love to put answers that could be correct answers or are answers to other questions as a wrong answer. And you will see a lot of questions about like packets and routers and networks and that sort of thing, where one of the answers has to do with encryption or security, that sort of thing, has nothing to do with encryption. Okay, this question right here is about the IETF, Internet Engineering Task Force. We talked about it at the very beginning of the year, and I think it's here. Okay, it's not even on the category, but it's in one of the videos. It's just a group of people that develop standard protocols for the internet. Okay, there are probably going to be more questions about networks than encryption. Okay, we're not going to have a cram session on this because we actually did this unit. Understanding, not just reading and memorizing, but understanding the vocab from unit 2 will do you a lot of good. Okay, protocols in general, internet protocol, transmission control protocol. Is that not on here? TCP. I don't think I got rid of it. Okay, well, either way, TCP, IP, all those things. Is TCP on here? Transmission control, am I blind? Either way, networks are good. Okay, so this question has nothing to do with encryption, but it is a question where they give a encryption as a wrong answer. Okay, in public key cryptography, sender uses recipient's public key to encrypt a message. Which of the following is needed to decrypt the message? The recipient's private key. That's all you need to know. Well, I mean, you need to know all of this, but for the answer, the recipient's private key is how you unlock the locked message. Okay, which of the following example of symmetric encryption? Okay, if it buys a lockbox that operates 2 different codes, okay, automatically this is not going to be a symmetric example of symmetric, 2 different codes. Finn and Gwen develop a system that maps each letter of the alphabet to a unique symbol using a secret key. Finn uses the key to write a message. And Gwen uses the key to map back to the original letter. That's the definition of symmetric, or that is a perfect example. Same key is used to encrypt and decrypt, and it works, but you can't send the key because the key is what is used to unlock it. You would each sender or recipient has to have the key, handed to them, essentially. And we won't go through the other examples there. Useless. Okay, internet users send a private message. Which of the following provides the most security when transmitting private data? Okay, certifying data, Creative Commons. Creative Commons, there will probably be a question, like exactly one question. Come on. Let's type something. Shoot. What is going on? I should have made this a PDF. I wouldn't ruin it. Creative Commons has to do with intellectual property and having works certified as public so others can use them. There will be one question about Creative Commons. This has nothing to do with Creative Commons. Creative Commons is nothing to do with security. Okay, high bandwidth has nothing to do with security. Public key encryption is security, and redundant routing has nothing to do with security. It does ensure a message will get through, but do not confuse that with sending a secure message. Okay, which is the best certificate authority, protecting data. Certificate authority has nothing to do with viruses. It doesn't issue passwords for secure databases. IP addresses and servers. Okay, certifying that IP addresses and servers are hosted, where they're hosted is domain name system, and certificate authority verifies encryption keys, which I don't think certificate authority is one of the vocab words for unit encryption. No. Unfortunately, that is one of the questions, though, even though we don't really talk about it. But here you are, it is this one. Okay. So impact of computing is, there's no way it's in the last one, is it? No, that is the last one. Okay, well, either way, moving on. Let's see here, which of the following explains how IP addresses are assigned. IP addresses, Internet Protocol is, you should know the term IP address. It is the addressing protocol. It has nothing to do with encryption. Okay, a new device is connected to the internet. It's assigned an IP address to enable communication on the network. That's it. Has nothing to do with security. It's giving each device its own location. Okay, IP addresses are assigned only to servers. No, every little thing connected to the internet has an IP address. New devices are connected to the internet without an IP address, but are eventually, nope, they get it as soon as, that's how anything gets any information, is having an address. And new devices are connected to the internet without an IP address. They're only for encryption, nothing to do with encryption. IP address is network protocols. Okay, transmission control protocol, TCP, and internet protocol are used in internet communication, which best describes the purpose of these protocols: to ensure communications between devices on the internet are above minimum transmission speed. Has nothing to do with transmission speed. It may help speed, but it's not about that. Ensure private data, no, has nothing to do with privacy. Establish a common standard for sending messages between devices. Okay, protocols are public standards. They're common standards that everybody knows so that the computers can talk to each other. Okay, again, has nothing to do with encryption. That is TCP IP. You need to know those things. Author of an ebook publishes no rights reserved Creative Commons license, which the best explains the consequences. Contents of the ebook will be encrypted, nothing to do with encryption. Individuals can freely distribute the contents without needing additional permission. There you go, that's what Creative Commons means. And not legally prevented, all that kind of stuff. Okay, which of the following best explains how devices can be susceptible to unauthorized access if weak passwords are used? They're going to give you a lot of ways that someone might get unauthorized access. They are specifically asking about weak passwords. Okay, a hacker trying to overwhelm the system, that has nothing to do with weak passwords. That is just brute force type of thing. Individuals can exploit vulnerabilities, compression algorithms, nothing to do with weak passwords. Hackers can exploit vulnerabilities in encryption algorithms. Weak passwords have nothing to do with encryption. Unauthorized individuals can use data mining and other techniques to guess a password. Weak passwords are susceptible to guessing. That's what you need to know about that. Okay, which is following is true about the internet. Internet is a computer network that uses proprietary communication protocols. Proprietary means private or privately held, or a company's intellectual property. The internet is not proprietary. It is a public standard. Everybody has access to the requirements for using the internet. Okay. Internet is designed to scale. It is designed to scale. We watched a whole video about 340 undecillion new users or new devices on the internet. It was one of the first videos we watched. Okay, it is designed to scale. The internet requires communication. The internet does not require encrypted communication. You can send your personal information on the internet all you want, and not just like you send it. You could write, someone could make software that unintentionally sends your personal information, the internet will let you send it. It doesn't matter. It's just as long as you're following the standards with IP address and packets and that sort of thing, your message will get through. Okay, the internet uses centralized system. No, the internet uses a distributed system. The routers make it so that there isn't one place that all the messages go through. Okay, that helps reliability and redundancy, or rather redundancy helps reliability or ensure messages. Okay, nothing, internet has nothing to do with encryption protocols or the standards of the internet. Okay, which is a public key encryption transmitting message. Public key encryption enables parties to initiate secure communication through an open medium such as the internet in which there might be eavesdropping. This is like a definition of public key encryption. Okay, I guess we'll go through the other ones, you know, for learning. Public key encryption is not considered secure. I mean, it is considered secure. Public key encryption allows encryption of documents containing text, documents containing audio, video, and wait, hold on. Public key encryption, only allows documents containing text. Documents containing audio, video must use a different encryption. No, everything can be encrypted using public key encryption. That's another concept that you will probably have exactly one question about, and that is how everything can be every piece of information can be simplified down into bits, whether it's audio, visual, text, some combination thereof. And that's what encryption is working with, is just basic data. So it is not that. Public key encryption uses single key. No, public key encryption, multiple key encryption, or just two key. Different than multi-factor identification, which is when they text you a code when you try to log into a website. It's a good thing. But multiple keys for public key, private key, and asymmetric. Those are all the same things. Public key and asymmetric are the same. Does require private key, but I suppose symmetric also has a private key. Okay, which of us exemplifies key logging to gain unauthorized access. A user unintentionally installs a program on the computer that records all the user's input and forwards it to another. A few weeks later, someone is able to access using recorded data. This is what a key logger is. It's malware that is installed on a computer and keeps track of every click. Somebody can look at every click and figure out which of those clicks were the password, and then you can just log in using the password. The bad guy could. Okay, symmetric encryption, how they're typically used. Symmetric encryption uses a single key that should be kept secret. The key is used for both encryption and decryption. That is what symmetric key is. One key, encrypt and decrypt using the same thing. Obviously needs to be kept secret. And there might be one more. Nope, I think that's it. Okay. Does anybody have any questions about this topic? Here's this thing to memorize. All right. So I think we're probably about done. I will post that recording for you. And again, like this, make sure you look through the algorithm cram session 1. But that's it. I'm not going to see you before the exam. So good luck, everybody. That is all.